This video covers pre-calc notes 1.10. We're going to be dealing with the concept of variation, specifically direct variation versus inverse variation. So when we are dealing with a direct variation equation, essentially what that means is that as x increases, so does y. On the other hand, if x is decreasing, so will y. It's called direct variation because it's changing the same way. It's either both increasing and they're both decreasing. There's a lot of different ways that we can say direct variation. We can say it by saying that it varies directly, so we can say y varies directly as x. We might change the wording a little bit in saying that it varies proportionately or directly proportional. Or we might even actually say a third way, which is that it varies jointly. But all three of these are letting you know that it's direct variation. And so you need to pay attention to the different wording to understand when you see varies directly, directly proportional, or varies jointly, that means direct variation. And so when you see direct variation, understand that you need to write it in the form of an equation that looks like this. Y equals k times x. So in this equation, x and y simply stand for an xy coordinate, or they'll stand for some units of measurement depending on what our equation is. The k is the important part. The k is the constant that tells us how our quantities are being varied. So the relationship of x and y is based upon that constant. And that's typically what we have to find first, is what is that constant, and then we use that constant to help us come up with some values based upon specific xy values that will be given. If we shift gears here, well actually before I do that, so I don't forget, I would highlight this or circle it. That is a formula that you're going to need to know, and you're going to want to make sure that you understand that that is direct variation. On the other hand, if we talk about inverse variation, if we say that it varies inversely, or if it's inversely proportional, that means as x is increasing, let's say, y will decrease, or the other way around. As x decreases, y increases. That's what inverse variation means. And the equation we use to write that is y equals k divided by x. So we're either timesing the k by the x, or we're dividing the k by the x. And again, another formula that you need to know and understand that this is the formula for inverse variation. So let's look at some examples and apply these two different formulas. The circumference of a circle is directly proportional to its diameter. So when I see directly proportional, I want to think direct variation. So y equals k times x. When you have a story problem, though, instead of using the y's and the k's, let's use the variables as what they start off with. So what I mean by that is, if it's circumference, we'll use a c. If it's diameter, we'll use a d. And that way, when we go to use this to help us solve for something, then we know exactly what we should be plugging in for. So if I say that the circumference of a circle is directly proportional to its diameter, circumference is directly proportional, so circumference was the first value, that was the y, is directly proportional means take the k and times it by some x value, and that x value would be the diameter, because that's the second variable in my problem here. Well, we should already know what this equation actually is. Circumference equals some constant times the diameter, and that constant is pi. So this is just an example of a formula that you already know, and how you could use it to help you understand the concept of direct variation. And that should make sense. You know, if you think about these circles here, the circumference of this circle depends on how big the diameter is. So as I increase the diameter, notice that as I'm increasing the diameter, the circle is getting bigger. As I increase the diameter, the circumference, or the outside of the circle, is getting bigger. And so that's what we're saying, is as d is increasing, so is c. And that's really what this equation is showing us. In the next example, it says y varies directly as x when x is 5. Y is 3. What is y when x is 20? So there's a lot of information in here, and you don't use it all right away. First thing you do is you look at this and say y varies directly with x. That's direct variation. Okay? Then the next thing you'll do is you'll deal with this piece of information. If you know what x is and you know what y is, let's find the constant. So that's what we have to do next. Find k. So x is 5, y is 3. So our equation would look like this. Divide by 5. I'd find that k is equal to 3/5. So now I can write the equation for direct variation as saying y equals 3/5 of x. And this is an important step to do because I can't really do this portion of the problem until I have that. So don't forget this step. And I'm taking the time to write this down because as I have taught these sections in previous years, I noticed that a lot of students don't take the time to write the equation down. And you want to make sure you do that because now you use this equation to help you solve this. What is y when x is 20? So in your equation that you wrote, x is 20, we would do 3/5 times 20, and we'd figure out what y is. So that would be 12. So I really have two answers for this. I have the equation that shows how x and y are related to each other, and then I have the actual value of y when I knew what x was. For this next example, it says, according to Hooke's law, the distance that a spring is stretched is proportional, keyword there, to the force of the spring. So right away, it says the distance stretched is proportional to the force. So normally we write our equation for direct variation as y equals k times x. But if they give us specific quantities for y and for x, let's use those variables. So I know that y is the distance because it comes first, so I'm going to put that as a d. K is always k, so I keep k as k. And then proportional to the force, that has to be the x value. Take the time to change the variables because when you start to plug things in, a force of 50 and the distance is 5, you know exactly where to put them. But if you have them left as y's and x's, you may not necessarily know where to plug these into your formula. So please take the time to write the variables as a d and an f instead of a y and an x. So it says that a force of 50 pounds stretches a spring 5 inches. I have to use all of this just to be able to write the generic equation. I can't do anything with problem number 1 until I know what my generic equation is. Okay, so that's important to know. I'm not going to do number 1 at all. First, I'm just going to write my equation. And the way I'm going to do that is I'm going to go through and plug in what I know. A force of 50, so in this equation here, k times 50 should equal the spring being stretched to 5 inches. The distance is 5. So if we divide by 50, we end up getting 1/10 as our constant. So my equation would be d equals 1/10 f. And that's going to be important because now I'm going to use this equation to help me do number 1 and do number 2. And again, a lot of students like to skip this part, writing the equation, and then they struggle with this because they never took the time to write your generic equation to find k first. And that's a huge aspect of this section of notes, is making sure you know how to find k, then using that to do something like answering question 1. How far will a force of 20 pounds stretch the spring? In other words, find d when f equals 20. So let's plug that in there. D equals 1/10, and then f would be times 20. So I know that 1/10 of 20 is 2, so the distance would be 2, and when we're talking about our distance in terms of inches. On the other hand, if it says what is the force, so we want to find the force, or find f when the distance that the spring is stretched is 1.5. So again, go back to your generic equation up here and plug it in. D, which is 1.5, equals 1/10 times f, and f is what I'm trying to find. So to solve for this, I can divide by 1/10, or I can times by 10, because that's the reciprocal, times this by 10, and I can do that math in my head, so that would be 15, as opposed to dividing by a fraction in my head, a little bit more difficult. So I'd find that my force would be a 20 or a 15-pound force to stretch the spring. So 15 pounds of force to stretch it. 1.5 inches. Okay, but again, I think the key to this is first changing my equation to this and taking the time to make the generic equation once you actually know what the K value is. So don't forget to do that.